Good morning, everybody. Millennium to power millennium. Good morning, everybody. This is Engineer Suraj Singh speaking from Bharat, India on this day, March 10th, 2022, Thursday. Early morning, it's now 4 o'clock, 4 a.m. and today is Thursday. नमस्कार, मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक मार्च 10 2022 थर्सडे बृहस्पतिवार सुबह के 4:04 and now I am present to you. I am here to present to you quality coordination, engineering projects works, reliable engineers, communication, concrete, civil, engineering works, contracts, design, safety, etc., etc., whatever title, miscellaneous titles for this general talk every day. Maybe this is first of all, let me introduce myself through my email ID, and that is Suraj_engineer. You can see this Suraj_engineer at yahoo.co.uk. If little up, I take Suraj SURAJ_ENGINEER at yahoo.uk, and inside this is Chartered Engineer India and International Professional Engineer India. Just for my introduction, it's nothing that it's usual. Many people are chartered engineers in this country. In other country, many people are professional engineers, and many people are having many other professional certifications as well as academic certificates, highest standards. And I am talking on behalf of all, particularly for this civil engineering works, though nothing is civil engineering perfectly, but civil engineering is a leading domain, and this is my certification of International Professional Engineer. This is Chartered Engineer India. This is fellow membership of FI is called, which is highest grade of membership. That is corporate membership, written as FIE, and that is, we can write like this. This is FIE, you can see here. And I'm just introducing again for some knowledge that it depends on experience and your achievements in life. And this is coordination engineering file, which I usually it's under construction, of course, but it is giving a lot. It depends. And this is quality file, which also now I close this file, fellow institution of engineers India, and I close this file, chartered engineer also. So I got more space on this because I have to discuss something on you can say some statements, and that's very important from point of view of quality, how works are done. It's not that every day I keep same file. I open many files, close many files, and then during session also I move on to various websites to search something. But my problem, which I have been experiencing, is different. That I can say today that it's very difficult to find important information even from internet in this age regarding quality and coordination. Quality and coordination, which are very significant issues for me. You can say quality and coordination, and I talk about that. This is a quality file, which speaks a lot. It speaks a lot not only of our country, that in Bharat, India, it also speaks for other countries. So I can keep this line up, and we can say quality and coordination. Quality and coordination are combined terms I'm using now, because quality is perfect, but coordination is not physical. Quality can be seen, it is a requirement of physique, means you have to produce something physically with inbuilt properties, inbuilt standards, and that's called quality product. While coordination is a procedure that doesn't give any delivery, but it helps delivery of quality, which is along with product is included. It cannot be separated, or you can say I have extracted quality from this product, and this is product as well as this is quality. That cannot be said. And coordination is a complete outlook how you have done it. In fact, coordinator has many tensions, many concentrations. Coordination means complete sequence of every step. There may be many steps in certain work, in certain activity, in certain job. Technically, particularly, if one step is missed, it cannot be checked. It happens, particularly in construction. In other fields, I'm talking of constructions very possibly, because construction, if it is done first, and once it is done, in civil engineering, it is very difficult to bring back to original state. Cannot be. Once you have done something, it cannot be changed, particularly when it is like material like concrete or material like mortar. Which domain, which materials rule domain? Concrete name itself says it is very strong, and so strong that we cannot break it even by our own normal hammer. And suppose we break it also, we cannot bring it back to its original ingredient state. That's why we say concrete is something that is permanent, because we cannot bring it back to its ingredient as we started mixing in dry position. Quality and coordination are therefore very significant terms. These are so significant terms that it's very difficult for everybody to understand quality and coordination, though everybody speaks about quality. My product is quality, I am a quality person, this job is quality one. Everyone claims, if you see even on products which are not civil engineering based, you shall find quality. This is our constituents, this is our ingredients, and we have done quality work, or we have best quality. You will see on web, internet, you will find products advertisements as everybody claims to be best. This is best suitable for you, and if you see another variety, same thing happens there also. Everything is best. That is you can say policy to promote sales and nothing else. I can say performance is not guaranteed. And somebody guarantees performance, that is maybe for 1 year, 6 months, 2 years, 1.5. Likewise, this means that is also limited. There's confinement of warranty. This means product is not fully guaranteed, to be very frank. Okay, I don't say that. It depends on standards, it depends on how much money you spend on that and what level of quality you define. Sometimes we don't define absolute level of quality, we define only part level, and customers know that this is my I mean to say, if 1 year is passed and the quality is guaranteed for 1 year, and you can say, okay, 1 year has gone now, my quality achieved, and people get satisfaction like that. Though no, because they have no other alternative. Why we should say money is permanent, you use money for future. If you save it, you get benefit. But it doesn't happen when you buy some material, some product. Even it's very expensive, it doesn't give you that level of quality which you expect. And that is business tactics of marketing. But we are talking here about quality and coordination. I'm not talking about marketing. I'm talking about engineering of production, engineering of manufacturing, engineering of construction, engineering and designs, and engineering and research, and whatever we say. Coordination is a part which applies everywhere. It never stops. Coordination is linked to communication, and communication also never stops. Even if you don't talk to someone, you can communicate to yourself also, and it happens. When you are silent, you talk to yourself, and you keep on thinking if you are really a thinker. Engineer is expected to be thinker. Engineer cannot be, you cannot pass engineering if you cannot think. That's very simple. It's like medical, if you do not know everything, you cannot become a doctor. Same way, if you do not understand concept of, or you can say basics of product or basics of theory, everything you have to understand, even though it's not everywhere in your program. Wherever you understand it's perfectly right. Only then you can answer question, or you can solve numericals, or you can do design work. And if you miss even one or two formula, you will stuck up, you won't move further. And that's where it's important to understand that how valuable it is to think and to work out and to calculate, to do. It's very, very important one. And that's why I say quality and coordination are of that level. We have to understand very clearly, quality and coordinations cannot be achieved without your concentration. In fact, I can say coordination is concentration. It's a sequence to move from one point to other. You cannot say I start with 1 point, I reach to 9 point, directly leaving 2 to 8, and you cannot come back to 2 to 8. If you can come back to 2 to 8, in that case you will say, okay, I first reach 9 and then I'll be moving back to 8 to 2, or if sequence allows. But this is not coordination. Coordination means you are not moving alone. You have to move others also. That's the job of coordination. Means I don't expect others who are involved in this to coordinate themselves, but it's my duty, if it's my responsibility to get information from those people or to get their involvement in my work. I'm saying my work means work of everybody here. Don't take it otherwise. Coordination is that process, that formula. In fact, it is that engineering which moves others to do their engineering. Coordination is that branch of, though it's not branch, you may say it's a state of engineering which involves connections to other branches or other disciplines or sub-disciplines which are involved in your job. Those must be timely accomplished. There is a time question, there is a quantity question, and even if it doesn't happen, your job cannot be completed. And if it's completed, it would be defective, you may say. There will be requirement of non-compliance. It's okay, it's not complied, you do compliance with that. So you have to understand why compliance is important. It's like our body is a unit, it is a plant, it's a process, you can say. If you consider our body which has a physical structure as well as a soul structure, both work together. And even one part of body, if it becomes defective, you feel pain, or there may be some problem in your body. For example, if my mind doesn't work, how can I feel? If my arms don't work, how can I feel? And that's what I'm saying. Engineering, you are constructing a body. You are different. You are not medical scientist who is just trying to treat body, but we are here to make a body and to treat that body. That is difference between engineering and medical. In engineering, we design. First stage is we design something, and before design, there's another stage, we conceive, we imagine, we have dream. So that dream, okay, we cannot measure that, we cannot pinpoint that stage, but design we can measure, we can evaluate what time and what theory and what formula and what way. So many points we can consider in designs. Then design goes to working mode, that we have to work it. And once it's worked, it's called engineered. Means design has been engineered to physique. You can say that. So design means it is a part of engineering, and working on that to physical form is also a part of engineering. And when physical form is done, delivery is made to person. But when design part is done, it is also delivery, but it's delivery only for doing job. So both are deliveries. Design is very important for works, and it is duty of every engineer working on designs to do design work in a quality way, in a coordinated way. And same applies to works on physique, that is on sites, that everything should be right. It seems that it's not possible to have everything right, but I would say it is possible. It is a question of commitment, it's a question of concentration, it's a question of keeping your eyes focused on what you want to achieve. So quality and coordination cannot be defined that these are different. I think these are requirement. And if an engineer cannot do it, then there is no one else who can do it. That's also a point. So we say we have to think always of quality and coordination. It's not a question that every day I start talking like this and you may start feeling what nonsense every day is talks on coffee. But that is very important. It's I talk about your soul of your body. If your soul and body is not workable, what shall you do? Think of that. You are a very good person, you are healthy, you have fine mind, you say, but I don't use my soul, don't care for my soul. And if you don't enrich your soul from power point of view, it's just like that you don't provide electricity in your machine and you think machine can work. Yes, if there is low voltage, your machine cannot work, and if there is high voltage also, your machine shall burn. And that's what I said, normal voltage, normal application is important. And if you increase power of machine, efficiency of machine or output of machine, you have to provide more power to machine, and that's what is important here. We have to care about quality and coordination, and quality and coordination cannot be defined in just in a way. It is to be understood very well. And that is an important point we have to think here, we have to discuss here. Without this we cannot move. So quality and coordination are very important points we have to clearly understand, and that's why I call myself that. I have to get up I have to get up in quality myself, and I get coordination and coordination, and I can't sleep on this. It's very, very significant matter, and we cannot say we say we require it. Actually, we have to understand it. Just saying we know quality is not enough. We have to prove that we do it, and we have to check ourselves, and we have to check our work, and we know that we are very competent people as far as this, because this is basics of engineering. What is quality, what is coordination, what is thinking, how to think, means whether it is logical thinking or it is empirical thinking, we have to do ourselves. There are so many formulas which are based on empirical world and engineering, and there are many generally formulas which are derived, and derived and logical and empirical are based on observations and experience. That's we have to understand very clearly. And quality engineering and coordination engineering are very important. Quality engineering also cannot be measured in terms of physical measurement. Same way, coordination engineering cannot be proved that coordination has been done. It's the result, its product that speaks. It has been well coordinated. So these both are like dreams. Product has quality. It cannot be defined, can be proved except by testing. Same way, coordination engineering can be defined or can be proved only by standard of product or current status of product. So we have to be very clear about this issue. We cannot just keep it on without any other formula. So we have to think of this. And now I go back to coordination. Before that, it's a fixed quality in our country, come what may, and no excuse for concessions. And that's very important statement. That we have to fix it. I'm not saying everything is bad quality, but generally, we see quality is not given value, and it's general now. Previously it was in selected areas, but now what based on experience or observational I can start, it's very, very general that we do not care for quality, and we have to care for quality. And for caring for quality, we have to coordinate every information, every work, every act, and people who work, they should know what they have to do. And therefore, we can say quality can be achieved, works cannot be compromised as far as quality is concerned. And we cannot just depend on quality system, we have to depend on quality information, quality implementation. And we may say, if we don't do it, quality system may fail, quality works may not be delivered, but we have to deliver, which is a must. We have to keep that point very important. And whatever red lines come on our way, we have to resolve those red lines. And red lines are many, and I have discussed many times. So we go to coordination engineering at this moment. It's very important point now. So my coordination, I'll come back to coordination. In this regard, I can say coordination engineering projects and public engineers. We have a question here, a very important question. Yesterday I posted also, and there are so many questions. The question is coordination? Let me just blow it up. And let me just say blow it up. Number one is coordination engineering a must? I repeat it, is actually is wrong. Is coordination engineering a must on every project? Few questions to be answered by community. Quality and coordination, and we can say, what do we engineers think over issues as mentioned? How many of us do conduct works per quality and coordination engineering? Is it not right time to contemplate and deliberate on this issue, on this subject? Can good individual practice be achieved without going through quality and coordination? Can engineering designs be reliably carried out without involving quality and coordination. Now, these points are very limited. Just to start with, we have to think about that, what to do, how to do, what's important, what's not important. That point is very wonderful if we understand that one. It's easy to say, but it's sometimes very difficult to do that. Saying is very easy, doing is difficult, and that is, you can say, time we have to think of, we have to understand. It's not simply that we can claim only. We have to do job. We have to do job very well, and we can say, what I mean to say is, just a minute, let me check. I posted that somewhere. Topic reply quote. No, it's not that. Okay, I actually was trying to find it somewhere. I posted yesterday about this issue. My question is very simple, and it's for everybody to respond to if you can. There's no hard and fast rule on this. First question is coordination engineering a must on every project? What should be your answer? I think your answer would be yes, it is a must. But just saying that it is a must is not enough. For saying must, we have to understand what we are talking of. Without coordination, can we do engineering? That's also a question. If we do design work, in design also coordination is necessary. Coordination of whatever information we have, whatever information we require, whatever knowledge one has, and whatever extra knowledge is required, or to find knowledge from elsewhere. And whatever knowledge we have to link every point in a way that it can be applied, it can be used. Redundant information does not help, same way deficient information also does not help. We have to replenish deficiency, we have to fulfill it. If we cannot fulfill that deficiency, whatever good design we do, defects means defects. So coordination engineering, I can say, people say engineering coordination, yes, that's also right, but I would say coordination engineering, because if we engineer coordination, it's something different. Means we have to think what we do in a coordinated way. It's not that we coordinate information, but we have to use coordination as a process, and that is through communication. And particularly you can say communication medium can be called track for coordination. It's a track where you have to move. If you move without that, you will lose everything. Coordination has many meanings. It can be called that you have to keep everything in sequence and functional. You have to operate every information if that is useful, if that is required. And even if you have extra information, we can try if it can be used in a better way. If it can be used in a better way, then it can be replaced. It can replace other information which was used earlier. In that way you can say it's a kind of quality upgradation. Yes, it can be called. When we say we have information based on quality, known information, in fact you can say we have to do all what is required. And it should be done on every project, design project, construction project, or you may say even other projects which cannot be seen, like quantity engineering, like research work on projects, operational research I want to say, or like you can say analysis on what we have achieved, and that can be defined in you can say lessons learned chapters. I'm calling it chapters because we have to learn lessons based on our work. Every project is a school, is a university for us. We make mistakes and we do best work also, we do commendable work too. We save time also, we use optimum of our time, our money, our you can say workforce, machinery. There's a long list of resources. on construction, in industry, that can be used in a better way. And top of that, we use natural materials. We should not forget. We cannot spoil natural materials, and that is first way I have to say in engineering world, that we have to think of using natural materials in the best possible manner, because ultimately it it adds to pollution also. So we have to think that way. We have to use minimum material for maximum gains. And that's economy actually, to be very frank. Economy is not in terms of dollars or rupees, it's in terms of how best we can do, because this globe or earth, we can call it, is our property till we live here. And we are, you can say, like security guards for this. We are not owners, because we are not permanent here. So we have to think of this home, maybe how long you live here. We have to think of to make it better. We have to think how to make it better, and that is what engineer does. Job of engineer is not just to product evaluate or product delivery. Job is to make product. Engineering is to make product, and how you make product, it is in your hands, in hands of engineers, that how best we can make it. And if I concentrate on quality coordination, automatically product is controlled. I say quantity is very important, but if quantity is seen only from quantity viewpoint, and viewpoints of quality and coordination are not taken care of, in that case I am helpless. I don't do my job, very frankly speaking. An engineer does not do his job. If engineers ignores quality and coordination, it therefore makes no difference between status of engineer and status of ignorant, or those who are just have no engineering cadre but workers in shop. Though I cannot blame them also, because they are experts on their own field, but they are controlled by, every worker wants to give quality, and that's also true. I did not find any worker. Of course they may say it's okay, this tolerance is okay, and chalta hai like this, because that person is taught like that. Worker has no fault of its own. This fault of engineer, this fault of those to whom workers report to. So I should say it is engineer. In fact, it may be engineer, it may be manager, whosoever it is. They are not good in quality education, and in fact quality education is absent in university. Quality of education is operative on sites, and if on sites work is done not per requirement of quality or per specification, in that case those who are not very well educated in engineering, they will learn all bad. And it is happening that our workers do not learn quality processes, quality products during construction, and particularly civil engineering I am talking, because civil engineering is a branch that applies to your life everywhere. It doesn't work. Even machine may be very good, it may be best one. If your foundation is not best or very suitable to that machine, either machine may fail or foundation may fail. You can say that. This is what I called. My question then is, few questions to be answered by community, and who shall answer this? Quality and coordination. That is my point. What do we engineers think over issues as mentioned? Yes, we have mentioned this. And it's the early start of quality discussion, quality of brainstorming. It's the question of brainstorming, you can say. I am storming, I'm attacking myself, I'm attacking whole community. What do you think of engineering? It's not just our duty to define engineering on papers or on charter or somewhere else. We just simply define this is engineering and we have to do it. But how are we doing it? That's the point of view. What do we engineers think over issues as mentioned, these issues? How many of our engineers, how many of us do conduct works per quality and coordination engineering? That's another question. You can say statistics don't define that. Just becoming engineer, claiming engineer, and not giving delivery of quality and coordination engineering is generally happening. It's not only civil engineering, you can see industrial engineering, You can see manufacturing, and you can go to market, see, buy whatever product, and you will really be upset. Generally, I can say, generally that quality, expected quality or quality that you pay for is not available. And that is the reason I'm talking. That's the only reason that quality and coordination I'm very serious about. I don't know why, but I have bad experiences in market. And you buy whatever you want to buy. I don't trust any manufacturer these days. I don't trust even top branded manufacturers because workers are same. Workers work same way everywhere. Brand won't solve your problem. It's good work that would solve problem. So I don't care for a brand even if it's top international. I don't care for that. It was a time that brands were valuable, but now brands are not valuable. We have to be sure that quality, whatever we buy, whatever product we buy, quality is available there. It may be product quality if you buy product, or if you may service quality if you buy services. Services are same, they charge a lot, but they don't deliver a lot. So it's a big question for everyone, and I think it is the right time. Is it not right time to contemplate and deliberate on this subject? My question is that, is it not right time? And I should say it is right time to contemplate and deliberate on this subject because we have been using natural materials in abundance, and once we use these materials, means these materials are gone. We have to value earth. We have to value ourselves in human form, and that's very important. We cannot convert every work into money value because that is relative value, that is not real value. Again I say, materials cannot be augmented on itself. Whatever material today in quantity form it is, after many years it will be same. Only equivalent value in terms of money can change, but quantity of metals cannot change. This point we have to be very clear about. We may be boasting about economy, we may be boasting about our valuation. That is different way, that's relative, that's not fact because quantity of material remains same. Many times I have given such quotations, such examples, that we say my house is X amount today, or it was X amount 10 years back. Now it is 15x or it is 20x, we can say. Okay, that can be in your unit, but in material quantity unit it is same, though it is depreciated otherwise because of wear and tear and because of continuous use of that and because of metamorphic actions, we can say, just like it happens on rocks. Some rocks are not affected by weather, some are affected by weather. For example, sedimentary rocks are affected by weather, but igneous rocks cannot be affected. Same way we can say, so question is, can good industrial practice be achieved? Can good industrial practice be achieved without moving through quality and coordination? And the question before it was, it is not right time to contemplate and deliberate on this subject, and therefore, can good industrial practice be achieved without moving through quality and coordination? Can engineering design be reliably carried out without involving quality and coordination? Only a few questions are just to start with. I just tried because I have been working on this file communication and coordination, and you can say quality. For a long time, quality you have taken a lot. I'm also presenting many projects and my reference for past, and maybe there will be hundreds of projects with you guys past. These questions are very initiative, primitive questions I'm raising about quality. Who should think if we can't expect politicians to think about this, we can't expect other people, other professionals to think about this, and we don't expect people also to think about this. People do not understand all this. They only want, if you sit in them, if you sit on a client and think what client expects, client cannot express what to say. It's okay, you do best for me. Client would say, oh, you give me a long running job. Everybody expects that. Tikau in Hindi we call it, durable in English we call it. Everybody wants durable job. They don't speak this word durable, but they say tikau or some other permanent or long living, some way, whatever way. We have to understand expression, what a common person expects from us. And that's point we have to think of. These questions are only for start, and these you can understand these questions. So what it says is coordination engineering a must. There's a question, and what's quality and coordination to understand, and what we say. What do you just think about this? As I said, and how many of us do conduct work according to the requirement of quality and coordination? And is it not right time to contemplate and brainstorm on this? And it can good in this practice be achieved in that point here. Can engineering design be reliably carried out without involving quality coordination? And we have to answer these questions in a positive way. And if you can't answer this question, I think I can only refer to past works done, but I can't claim anything on that because that is dream now for me. If I say this work I did in 1986, okay, I did it fine, you may say, why telling me? I'm not telling you that, not at all. I'm just trying to explain the status of quality at that time, our working capacity at that time, our learning that time, because works cannot come back to you. Remember, in construction, in civil engineering particularly, you can do job, you can deliver it, and after that it may not come to you back, or you may not go to it probably throughout life. And this happens. Generally it happens because first of all it is not one day manufacturing or a few hours manufacturing, and no manufacturing takes years because parts are manufactured and many parts are assembled. For example, automobile engineering, many parts are assembled. In some heavy machine, many parts are assembled. So these parts are manufactured elsewhere in many places. One machine parts may be, you can say, manufactured in 20, 30, 50 places, but assembly is done one place, and then you can say once machine is ready, is functional, it's sold, then it's different. One day that machine shall stop serving. But in civil construction, it doesn't happen like that. Civil is only world. That's why we call it civil, this public, this life. Civil is public and civil is life. And every civil engineer should think that way is better. If you think only in terms of monetary gains, then in that case I would suggest better not to join field of civil engineering, because civil engineering is like a field where you bring up everything. You bring up every person to higher status. That is what civil engineering is. It's not money that is civil engineering. It's natural support that is civil engineering. We have to develop our standards through civil engineering. Civil engineering includes other engineerings also with this. For example, architectural engineering. I'm not trying to differentiate in a way it should not be done. I am trying to differentiate in the way that civil means public and others are supportive. Civil engineering is public supportive engineering. Even, civil engineer has no right on to delivery, only duty. There is no right. Same way, civil engineering does not own its project itself, its people. But we can say quality, and you can say whatever else you can do, or you can say you add whatever more quality level to your work. That is your standard. Standards once achieved, that you cannot withdraw those standards of product, and you also cannot add to that. And so I can say it's very responsible job. Very, very responsible job. Don't think in terms of what position you have, what status you have as civil engineer. You are a kind of representative to use natural materials, natural raw materials, matters occurring in nature. You have got that small knowledge which God may be shared through engineering. That's an important point, because every project you deliver is your kid, you can say. is your disciple, you can also say, or you can say your offspring, you can say. And if how better is that, how better that serves, it's your value. If a building by chance you have time to see in your lifetime, you'll be either very happy or you'll be very upset when you meet it. If you have chance, if you meet that after many many years or many many decades, you will find your kid is weeping or it's laughing or it's grown up. You will find yourself. How many cracks you see on a building that time? How many millimeters of settlement it has achieved? Or what is position or status of concrete on that building? Or people may complain to you and you will feel upset. That happens. That's why I try to show. I'm trying to showing my projects in that regard only. It's not that I'm making any claim, because I'm not first engineer in this world. I'm not last engineer as well. That way, but everybody has, though others may forget, you may also forget. Only some records we have in our lifetime. All records are not possible, and because my career has been overseas for many, many years, and I did not have all those records with me. But due to technology, whatever records I can have now, that's I try to understand myself actually. What I did, what I did not do. That's the only point I can say. How we move. And it's very, very important for me to understand this. In fact, you can say I'm reviewing myself. Though there's no meaning at all in this age, but question is not age. Question is at least my information that I give to others can be useful in their career. And career is also not important, but commitment is important. You can say it is life. Some people evaluate this only in terms of money, but my question, my consideration is not money alone. Money is the other point. My point is I have to respond to God. Maybe it's my philosophy. Why you do not quality to this product? And I am scared about that. I know where quality was done, where response was done. No, every engineer knows that. There's no other way. You have to know it. And if I did bad job, then my conscience won't allow me to claim that this is my job. I want to isolate myself from there, but isolation is also not permissible. Bad is bad. Yes, intentionally if you do it, it is really crime. And if you do some mistake during training or learning, it's another point of view. So all these projects I'm trying to show to you, these are just, just you can say a kind of representation or a kind of reproduction, or you can say information. What I did something only in very small capacity, and that capacity whatever it was. But if current engineers, if generations, if now our kids who are moving towards becoming engineers, it would help them to understand what our past people, what our seniors have done. They did some mistake or did commendable jobs. They have affinity for both. And nobody can say mistakes were not made. I can openly say I made mistakes. I never say no. Why I should say no? If I do not make mistakes, then how can I learn? But these are not intentional mistakes. These are mistakes due to field problems, and due to maybe weakness of myself. I was not intelligent, I was not committed, I did not understand what to do. Maybe that could be the case. And it happens with everybody. But learning is learning. Because universities cannot teach everything, we have to be sure about that. And in practice, you can say, in perfect world, I can say, civil engineering cannot be learned practically in university or institutions. All right, theoretical part is fine, and some technical part is fine, but work part cannot be learned anywhere. No university has competency. No university has got any potential to teach these practical aspects of engineering Even construction engineering is taught by professors. That's only bookish way. Nobody can teach exactly what is done in field. Even if someone is doctorate in engineering, that person cannot say how construction shall be done in a perfect way because there is no such inclination, and that's why learning on projects is something different. It's not recorded, of course. It's not entitled. It's not titled in Daily Summary, but practical work it is, and we learn that. As much as we learn, we feel we have not learned anything, and that's beauty of learning. If I work my whole life and learn something, and I think what I did nothing. I just wasted so many years. I didn't learn anything. It happens sometimes. It means if there is no place in your memory, in your mind, to think about otherwise, you may say, oh, it's same as an empty brain. So you can say, I feel, even my say brain is full, I feel it's empty, because it's not telling me anything. That's what is very important. That way, I'm really screening out myself how to work on this. And there are so many projects I'm trying to show you with so many angles, so many points. I'm also giving in this file certain URLs. Well, I start posting these parts of work on web because this file is getting every day heavier in memory. It's not going. I tried. It's not working to post on somewhere. So I have to be in parts only. I'll post in parts because. But these parts, video-wise, I have to talk every day. Coordination, I can say. I can say the coordination is for me, for you, for everybody. It's up to individual how to take this. Some people, because coordination means you have to be very focused. That's the important point. Coordination is a responsibility of working. If I'm a coordinator and I don't do coordination correctly, it's my duty to make sure whatever information has gone to a worker must be absolute, must be detailed, and not confusing one. And that's why we know drawings are very important, sketches are very important, methods are very important. All these are very important from point of view of coordination. And this is only few projects. You may have done many projects. I cannot do maybe I don't think about that. And that point is really very important. We have to be serious on that issue. Coordination world. Maybe you people feel bored about coordination. I don't feel bored because coordination is life. If my mind stops coordinating, I cannot work, and that's also very important. Coordination, for example, I'm showing this is school. I'm sorry, hospital. Well, I was just very upset on this project when I saw very bad coordination. Really, structure was done correct means structure was over, RCC structure, and buildings were in finishing stage or in other stages, or is some working. This was complete haphazard. I joined it in 2000, I think 2010. I thought that I would do something, but I did not find any cooperation there. Nobody was very interested in coordination, and there was a big problem of coordination. And people just doing their way what they wanted to do. And that's why I'm trying to include this project in this quality talk, this coordination talk. And every hospital is important. It's a very essential way. It should not be compromised. But there were many defects in structure in this, as well as there were machines were lying, just new procured machines were lying here and there. If, for example, chillers were lying somewhere, and your other machines were lying here, and many other just lying here, package units, electrical lying here and there, package subsystems we call. We see coordination was very important, but there was no encouragement onto engineers from management or from organization. We find and nobody listened from organizations, and same way nobody bothers for consultants, what we used to say. But we say they were interested only in doing this job and getting more job on behalf of that, on same one. So it's not good experience, I can say. But you see, if machines remains standing on the capital site for a couple of years, for example, chillers or transformers or package units or whatever, pumps, what do you think will happen to that? Means that's not building this machine, and it can spoil without working. That happens. That's number one point in MEP, that if you don't install it properly, if you don't use that machine, that also becomes a problematic. You cannot say did not use it. It's still new question. It's not new old. Question is why it has not been used. So that's why I'm saying so much was seen there, and I tried to fight with circumstances. I did a lot, but people could not. They did not know what is coordination. And it's not only this project. Many other projects I've seen, people don't understand what is coordination. I don't know why, but maybe it's because of lack of education, lack of educational quality. And same though here, this LNG project, where we something different. Coordination is also important, but I was responsible for coordination. Another building, another project here, and which I did very well without any computers. I did all, you say, and presentations in form of certain, you can say, certain done jobs, not on my responsibility, but I learned. You can say I was a very small person on these jobs, but I learned from these jobs what to do, what not to do, and I cannot bring to you all the work I did because I don't have all records, so I should say that, but that's the important point we have to think of. What was, as I said, also this is a layout of something which was done, and you can yourself see how complicated it looks. Though it's not complicated while work, but detailing is very important. If detail is not important, what you do, how you do that, that's the point of view. And I simply say, don't otherwise. Details are very important everywhere, and these details cannot be taken for granted. And these details are very important point of view. And now we can, let's say, this pile that's in for project one, the same building which I say house, and I usually say that I talk of that again and again, again and again. In this, I have gone to so much. You can say that's where I start with that point of view. House construction plot. Let us say, let's start here and think of something. It cannot be simply said that. Let's first see what I wrote on that. That's the ground floor about structures, and before that, I should say, I'm just giving you something in this case how to start with. Let's say excavation. Method of surveying, or say excavation. I did that again. I read it for you, and we know at least what we have been discussing with. And its existing soil type is, say guilty. I explained before also. No dewatering required since it's clay soil and water table is down. And we use JCB to some extent. After that, we used donkey laborers, workers, and then you can say there was problem on three sides because buildings existed. We could not excavate blindly, and then excavated metal was removed as it was taken out, and we protected sides of excavation against rain because it's clay soil, and if it gets wet it can swell and come down and cave in, and that's the reason that sides of excavation protect by covering with polythene sheets so that rainwater does not help loosen strength in this case. So my first statement starts with existing soil which has silty nature, silty clay, and below that stands strata. That was a problem, and we had to take care of that. We had taken care of that, and dewatering was not required formally. So now blinding, we know what is blinding. Many people know not about blinding. Is an international term. It's used for first non-structural concrete, where we can say we site foundation on that. That's called blinding. Non-structural concrete for removing unevenness of formation level, and to bring it to the formation level, whatever thickness it is, maybe 10 mm, 10 mm, 100 mm, 75 mm, or 50 mm. That leveling course is called blinding concrete. Blinding means where there are maybe holes, some pit holes, or some other holes, or a non-uniform thickness, to bring it to a level field. That level field is really well defined, and we can say that it's blinding concrete, we call it. So we can say, since soil bearing capacity is not safe to allow heavy structures of this sort, soil improvement was conducted, and now blending was done on improvement itself. It was not done directly in formation level reach, but below formation level it was done. We can say we did soil improvement on this for purpose of, because we don't trust, we either trust in clay soil and because of clay is dangerous of containing Mount Morellonite within this structure. It contains very difficult, very non-cooperative material, mineral, and that's Mount Morellonite, or it may have alkalonite or some other, whatever it is. We cannot spoil that foundation. It remains in contact with soil. Such soil, which swells as well as restricts it both way. When you add more and more water to clay, it swells in many times, many hundred times, and also when you evaporate water from its pores, it can result in shrinkage, cracks. So we can say water contents are very important for this, and water content means you have to take very good care of this soil, or otherwise it will dry out because of its porosity value is not permeable at all. There is no permeability value applicable to silt. I mean also called clay soil. It's very difficult soil to understand, to gain, and that's why we have to take care of soil which is clay, and where this sand soil or granular makes that's helpful, but here is different case, and we have to give value for this point of view. So soil improvement was necessary, and it was done. It was done in a very professional way, that we replaced a portion of about 30 centimeter, 300 mm thickness below formation level from its existence clay to replaced, or you can say replace or re-strengthening using granular mix. That is first higher size and then lower size and then further lower size. So that was higher size of clays, but there may be many voids, say 50% voids or more. Those are filled by a little different size, lower size of aggregate, stone aggregate, and that will further reduce, minor sizes, and then you can say at very smallest size of grains, and that is the dust that goes into all those interstices, and we can say we pack it now using water, and water can bind all those particles, just like we do water-bound macadam road structures, base course or sub-course, whatever, and then we can say, okay, it's well compacted or rolled. It's better now. Our foundations are rest on now good ground and not in contact with mineralogical soil. That I call mineralogical soil. That is clay, and clay is not suggested to be used anywhere like that. But clay is good for agriculture purpose and not for construction purpose. The soil improvement is defined as that. With the soil improvement, and that's we actually increase the soil bearing capacity, because in clay, bearing capacity doesn't value much, but well, so sheer values were value of C works there, but in granular size, bearing capacity pays a lot. So we can see this layer composed of aggregate and coarse dust, duly watered and compacted, so that it should also function as a coarse grade strata, and that was actually meaning of that, very important meaning. Now my battery is a little up, it's fully charged. I'll put off switch, and we'll see how to do it, how to evaluate it and read. That's very important point for everyone, and for just a minute please. Now, as we said, is talking of something very important here, and we cannot deny these facts, that we have to be serious in our business. Now improvement is over, let us say. Now we have to further enrich this layer of improved layer, or layer of improvement. We have to take care of this. How to take care of that? That's another point. And that is, let me see temperature. Now we can again. I'm saying it's important one. See now how much it is. It's still 17. It is, so it's not very bad. 17 expected time in days, 31 and 16. Right, so 17 is good one, but we have to search also for different views. We have to search for, that's the soil improvement I'm talking, so it's very important part, and we know various process of soil improvement, why it is done, how it is done. I did this one. So this soil is loose surface material that covers most land. This is one slide. So generally we know soil is loose surface material that covers most land. It consists of inorganic particles and organic matter. Soil provides structural support to plants used in agriculture and is also their source of water and nutrients. Soil vary greatly in their chemical and physical properties, and that is what is said in some information, and that's good one. So soil is we can say soil is a soil is a mixture of organic matter, minerals, gases, liquids, and organisms that together support life. We have to understand this point, and we have to see how does it happen. It's very important. Let's soil in Wikipedia. It says we have to understand these points very well. If you really want the coordinate knowledge, you can say soil is a mixture of organic matter. It says there's a big, no, it's not big. Let me see. Let us see by printouts, and to show you also is very important. So let me see printout of this. We read in that case by printouts. You may also know what I'm talking of, because augmentation of knowledge is very important. It's not civil engineering enough. We have to brainstorm, and that brainstorming is important. That's what I'm doing, brainstorming on. It's not what I've written, that's enough. Means we have to understand the world also, what people think of. Maybe we get some information from this, with good information, and that's what, because of talking coordination, and coordination is got more information from sources, available sources at least, if we can't explore those sources. As we know what's available or what's not available, and that's a good point of view. So I expect this file to come up in the PDF form. Let's see how does it work. Still there's no coming out yet. It should come out soon, I think. Why it's not working? This is let me see. By the time we reach it, soil is a mixture of organic matter, minerals, gases, liquids, and organisms that together support life. Earth's body of soil, called pedosphere, has four important functions. It says a medium for plant growth, as is a means of water storage, supply, and purification, as a modifier of Earth's organisms. As of these functions, medium of plant growth and water storage and Earth's atmosphere, habitat for organisms. So these are there. So you can say all these functions in their turn modify soil and its properties. Soil is also you can say it's not coming yet. Soil is also commonly referred to as earth or dirt. Some scientific definitions distinguish dirt from soil by restricting former term specifically to displace soil. What's happening? Why it's not coming? I don't know reason. I think it's coming now. Yes, it's come. It took time, but it's come. It's very slow sometimes, so we have to see her soil. I want to show you. Oh, they have 50 pages. That's taking a lot of time. Let us see. Let us browse onto this. What it is used for? Will you go to? Talking of, that's also a very important point. So this is all browsing of 50 pages. Only few have come. So let us see. Long is there, so it's an important one. We can save this file also for our reference, and no problem. There will be references, of course. Many references are there. Doesn't matter which information that's used for us. That's good for us. We'll take only that information that we don't care for. So let me first of all save it, so that the print pages, and let me just save it for myself, and later we can use it. If not just now, it's useful and should be used. My statement I can take, and this is here I can say soil, and I can say construction itself, or we can say coordination. I can write for coordination. I can use coordination, so that we can use it, because I can't complete 50 pages immediately. It's therefore better to So let's say soil, what it defines with. This is Wikipedia. I'm just telling you it's Wikipedia. And this is soil is a mixture of organic matter. It's written clearly. And let me see also other way. Already some any other of something else. I have to go and soil Wikipedia it was, then soil definition importance. Basic soil.org, soil.org. I don't think it was that. Soil is a mixture of matter. Okay, this already done. So what is soil? Soil Institute of Management. I don't think it's very important. What is soil? And this is USDC. Okay, I leave them alone. Now we concentrate on Wikipedia. What says the important one? It says it's in relation to coordination of talking. Soil is, let's say, soil is a mixture. You can read yourself. I've blown it up. And soil is a mixture of organic matter, minerals, gases, liquids, and organisms that together support life. Earth's body of soil called pedosphere. Earth's body of soil called pedosphere, okay, this is a new term, pedosphere, has four important functions. As a medium for plant growth, as a medium for plant growth, as a medium means for water storage, water body, supply and purification, as a modifier of Earth's atmosphere, as a habitat for organisms. So according to this scientist, to this writer, it is plant growth, it is a water body or underground water, you can say, for supplying for purification. Earth's atmosphere it modifies, and habitat for organisms. All these functions in their turn, yes, you can say all these functions in their turn modify soil and its properties. Soil is also commonly referred to as earth or dirt. Dirt. Some scientific definitions distinguish dirt from soil by restricting former term specifically to displaced soil. Pedosphere interfaces. Pedosphere interfaces with lithosphere. So we reach again lithosphere, same. Pedosphere interfaces with lithosphere, hydrosphere, atmosphere, and biosphere. See how many spheres are there? This is what we study. This is what knowledge we do gain about this. Pedosphere, though it doesn't exist in geology, but pedosphere is linked to lithosphere, so coordinated interfaces also coordination. Pedosphere coordinates or interfaces with lithosphere solid part of earth, not air part, and air part plus lithosphere or air sphere plus lithosphere is equal to earth. Hydrosphere, there is lithosphere, hydrosphere, atmosphere, and biosphere. Now term pedolith as referred to pedosphere. Term pedolith used commonly to refer to soil translates to ground stone. Pedolith used commonly to refer to soil translates to ground stone in sense fundamental stone. From ancient Greek ground, there is a formula written here, term written here, pi epsilon delta omicron v. Ancient Greek ground earth, it's written ground earth, that is fundamental stone from ancient Greek. So I can say again, term pedolith used commonly to refer to soil, and this term pedolith translates to ground stone in sense fundamental stone, ground stone, from ancient Greek ground, that is ground here, earth, ground earth. Soil consists of a solid phase of minerals and organic matter, that is soil matrix, as well as porous phase. Of course, porosity is there, so it's porous phase that holds gases, which is soil atmosphere, gases, that is soil atmosphere, and water, that is soil solution. So soil also has got its atmosphere in forms of pores, which has soil atmosphere in forms of pores and porous, and that's called, there's atmosphere is called, soil atmosphere is called, there's gases contents in that atmosphere, and water that is also available in pores is soil solution. Accordingly, soil scientists can envisage soil as a three-state system of solids, liquids and gases. Solids, liquids and gases. So we know all that, gases. Now, soil is a product of several factors. See where we were just thinking of improvement, but now we are just trying to understand. If you have got some information, it's better to understand this for additional knowledge and more elaboration and more elaboration. Soil is a product of several factors. Influence of climate. Influence of climate it is. So climate has got relation to soil. So we should think in a different way then, because we have to take care of climate also. So soil has to help there. Soil is a product of several factors. Influence of climate. Relief. Relief, that is, you can say, elevation, orientation and slope of terrain. That's true. Elevation, orientation and slope of terrain. This is what it is. Climate and relief. Organisms and soil's parent materials. Original minerals, this is parent material. Original minerals, which interact together over time, or you can say interacting over time. It continually undergoes development by way of numerous physical, chemical and biological processes. You can say it continuously undergoes development by way of numerous physical, chemical and biological processes, which include weathering, weathering and associated erosion. Now weathering means erosion, of course, because weathering cannot be another. Smallest particle of soil can be removed by weathering or by wind action or rainwater flow. Now given its complexity and strong internal connectedness, given its complexity and its strong internal connectedness, soil ecologists regard soil as an ecosystem. So we have reached to ecosystem now. Soil relates to ecosystem. We'll review it again. I'm just going to preliminary record. Now most soils have a dry bulk density. Most soils have a dry bulk density, and we can say that density of soil taking into account void, voids when dry. Density of soil, that is, you can say, I just put most soils have a dry bulk density. Density of soil taking into account voids when dry. We take into voids when dry, right? Voids when dry. Between 1.1 and 1.6 gram per centimeter cube. So what is density? Density of soil taking into account voids when dry, between 1.1 and 1.6 gram per centimeter cube, while soil part the range of 2.6 to 2.7. Soil particle density is, I think I have to reduce it so we can take full here. It's now because expanded one, so we can say most soils have a density of the acid, while the soil particles density is much higher in range of 2.6 to 2.7 gram per centimeter cube. Little of soil of planet Earth is older than Pleistocene. Pleistocene, and none is older than Cenozoic. Pleistocene is a period and Cenozoic. So this is period, we cannot confirm this, but this is, you can see, we accept that way. Little of soil of planet Earth is older than Pleistocene, and none is older than Cenozoic. Although fossilized soils are preserved. Fossilized soils are preserved from as far back to Archean. That's different. We don't want to go to that one. We have considered engineering part of soil. So soil science has two basic branches. That's not what I would say. Soil science has two basic branches of study, and that is edaphology, EDA, edaphology and pedology. Edaphology is defined and pathology is defined. Now what edaphology is? Edaphology studies influence of soils on living things or living beings. That is edaphology, studies influence of soils studies influence of soil on living beings, living things. Pathology focuses on formation, description, or morphology, you can say description, morphology, and classification of soils in their natural environment. In engineering terms, I'm now talking of agroecology and pathology. We're talking in engineering terms, soil is included in broader concept of regolith, which also includes other loose materials that lies above bedrock, as can be found on moon and other celestial objects. So now our contents are processes, composition, formation, physical properties, soil moisture, soil gas, soil particles, chemistry, cation and ion exchange capacity and ion exchange capacity, reactivity, that's PES, space, saturation percentage, buffering, nutrients, soil organic matters, humus, climatological influence, plant residue, origins, classifications, uses, degradation, reclamation, history of studies and such, studies of soil fertility, studies of soil formation, see also reference. All these are contents of this, but we are just now going to do process, for example, what you say. Now, what we think of, we understand is function. Soil functions as major component. Soil functions as major component of Earth's ecosystem. That's true. Soil works, or you can say, as a major component or functions as major component of Earth's ecosystem. World ecosystems are impacted in far-reaching ways by processes carried out in soil, with effects ranging from ozone depletion and global warming to rainforest destruction and water pollution. Ozone depletion, yes, we know that, and global warming to rainforest destruction. Rainforest destruction and water pollution. Water pollution, rainforest destruction, water pollution. With respect to Earth's carbon cycle, With respect to Earth's carbon cycle, soil acts as an important carbon reservoir. With respect to Earth's carbon cycle, soil acts as an important carbon reservoir. It's potentially one of most reactive to human disturbance. Carbon, that is, you can say, with respect to Earth's carbon cycle, soil acts as an important carbon reservoir. And this is potentially one of most reactive to human disturbance and climate change. As planet warms, it has been predicted that soils will add carbon dioxide to atmosphere due to increased biological activity at higher temperatures. A positive feedback, that is amplification. This prediction has, however, been questioned on consideration of more recent knowledge on soil carbon turnover. Now, let us go further and see what it says. These are very common carbon dioxide issue. Soil acts as an engineering medium. That's now our issue. Soil acts as an engineering medium, a habitat for soil organisms, a recycling system for nutrients and organic waste, a regulator of water quality, a modifier of atmospheric composition, and a medium for plant growth, making it a critically important provider of ecosystem services. So what it says, soil acts as an engineering medium, a habitat. What is that? As an engineering medium, it helps in habitat for soil organisms, a recycling system for nutrients and organic waste, a regulator of water quality, a modifier of atmospheric composition, and a medium for plant growth, making it a critically important provider of ecosystem services. Since soil has a tremendous range of available niches and habitats, it contains a prominent part of Earth's genetic diversity. A gram of soil can contain billions of organisms. A gram of soil can contain billions of organisms belonging to thousands of species, mostly microbial and largely still unexplored. Soil has a mean prokaryotic density. Soil has a mean prokaryotic density of roughly 10 to power 8 organisms per gram. See, soil has a mean prokaryotic density of roughly 10 to power 8 organisms per gram, whereas ocean has no more than 10 to power 7 prokaryotic organisms per milliliter gram of seawater. Which says soil has a mean prokaryotic density of roughly 10 to power 8 organisms per gram, whereas ocean has no more than 10 to power 7 prokaryotic organisms per milliliter gram of soil water. Seawater. Organic carbon held in soil is eventually returned to atmosphere. Organic carbon held in soil is eventually returned to atmosphere through process of respiration. Process of respiration carried out by heterotrophic organisms. Heterotrophic organisms. But a substantial part is retained in soil in form of soil organic matter. Tillage usually increases rate of soil respiration, leading to depletion of soil organic matter. Since plant roots require oxygen, aeration is an important characteristic of soil. This ventilation can be accomplished via networks of interconnected soil pores. This very ventilation can be accomplished via network of interconnected soil pores, which also absorb and hold rainwater, making it readily available for uptake by plants. Since plants require a nearly continuous supply of water, but most regions receive sporadic rainfall, water holding capacity of soil is vital for plant survival. This we are talking for irrigation purpose, agriculture, and how much soil we talk of in this case can be realized by you. Ultimately, porosity helps in that it can connect, you can say, uptake of plants, and you can say also absorb and hold rainwater, and nearly continuous supply of water is available. So you can see plant roots need oxygen. Aeration is an important factor, important characteristics of soil. So this is aeration, and this ventilation can be accomplished via network of interconnected soil pores, which also absorb and hold rainwater, making it readily available for uptake by plants. Since plants require a nearly continuous supply of water, but most regions receive sporadic rainfall, water holding capacity of soils is vital for plant survival. Soils can effectively remove impurities. That's the important point. Soils can effectively remove impurities, kill disease agents, and degrade contaminants. This latter property being called natural attenuation. Natural attenuation, typically soils maintain a net absorption of oxygen and methane and undergo a net release of carbon dioxide and nitrous oxide. What it says, soils can effectively remove impurities. Impurities means kill disease agents and degrade contaminants. This later property being called natural attenuation. Natural attenuation. Typically, soils maintain a net absorption of oxygen and methane and undergo a net release of carbon dioxide. What does it? Absorbs oxygen and methane and undergo the net release of carbon dioxide and nitrous oxide. Soils offer plants physical support, air, water, temperature, moderation, nutrients and protection from toxins. Soils provide readily available nutrients to plants and animals by converting dead organic matter into various nutrient forms. Let's go a little composition here. I think it's a big file, but knowledge is better here. I think it's an interesting one for engineers to understand at least how soil functions and how does it help and how does it relate to engineering. Already we have reached to geological engineering, that is in terms of soil, in terms of other materials, percentage of this and that, and organic contents and minerals, that says. A typical soil is about 50%. A typical soil is about 50% solids. Typical, it's said, it's not mandatory. Typical soil is about 50% solids, 45% minerals, and 5% organic material. That is, 50% solids, 45% minerals, and 5% organic matter. And 50% voids or pores, of which half is occupied by water and half by gas. So it is approximate, I think, typical soil is about 50% solids, out of which 45% minerals and 5% organic matter. That is soil, and 50% voids or pores, of which half is occupied by water and half by gas. So 50-50 it is. Solids, soil is 50% about mineral organic matter and 50% out which is water and gas, 50-50. Percent soil minerals and organic contents can be treated as constant. Soil minerals and organic contents can be treated as organic content is treated as constant in short term, while percentage of soil, percent soil water and gas content is considered highly variable, whereby rise in one is simultaneously balanced by reduction in other. Pore space allows for infiltration. Pore space allows for infiltration and movement of air and water. Pore space allows for infiltration and movement of air and water, both of which are critical for life existing in soil. Compaction, a common problem with soils, reduces this space, preventing air and water from reaching plant roots and soil organisms. Given sufficient time and given sufficient time, an undifferentiated soil evolve a soil profile which consists of two or more layers, referred to as soil horizons. Given sufficient time, an undifferentiated soil evolve a soil profile which consists of two or more layers, referred to as soil horizons. This differ in one or more properties, such as in their texture, structure, density, porosity, consistency, temperature, color, and reactivity. Horizons differ greatly in thickness and generally lack sharp boundaries. Their development is dependent on type of parent material. Type of parent material, process that modify those parent material, and soil forming factors that influence those processes. Biological influences on soil properties. Biological influences on soil properties are strongest near surface. Biological influences on soil properties are strongest near surface, while geochemical influences on soil properties increase with depth. So, surface wise we can say what? Actually starts with that differs in one or more properties, such as their texture, structure, density, structure, density, porosity, consistency, temperature, color, and reactivity. Horizons differ greatly in thicknesses and generally lack sharp boundaries. Their development is dependent on type of parent material, processes that modify those parent material, and soil forming factors that influence those processes. Biological influences on soil properties are strongest near surface, while geotechnical influences on soil particles properties increase with depth. Mature soil profiles typically include three basic master horizons. Here are A, B, C, R. A, B, C, R. We have soil profile, darkened topsoil and reddish subsoil layers, and typical humid is down, and likewise we can see that. Include three basic master horizons A, B, and C. Horizons A, B, and C. Column normally includes A and B horizons. Living component of soil is largely confined to column. Largely component of soil is largely confined to column and generally more prominent in A horizon. A horizon is more important. It has been suggested that pad on a column of soil extending vertically from surface to underlying parent material and large enough to show characteristics of all its horizons could be subdivided into humi-pad-on living part, where more soil organisms are dwelling corresponding to humus form. Cop-down in intermediary position, where most weathering of minerals takes place, and lithopad-on in contact with subsoil. I'll read this again. Normally, this you can say includes A and B horizons. That is, you can say if you take mature soil profiles, it is mature soil profile typical include three basic master horizons A, B, C. Normally includes A, B horizon, that is solemn. That is solemn. That is solemn. Let's a minute. Why he has written this term solemn? That's a point of concern. Let me see this dictionary and see solemn. What does it mean? I should be clear about this. Why should I speak for nothing if I do not know? Solemn. In English, solemn is plural sola. Solemn in soil science consists of surface and subsoil layers that have undergone same soil formation conditions. That is solemn. Base of solemn is relatively unweathered parent material. Solemn and soils are not synonymous. Some soils include layers that are not affected by soil formation. So soil we could be is solemn is plural sola in soil science and consists of surface and subsoil layers that have undergone same soil conditions. So we go further and see, you say solemn, we are talking solemn, normally includes A and B. A and B, living components, you can say living components of soil is largely confined to solemn living components and generally more prominent in A horizon. A horizon, it has been suggested that Padon, a column of soil extending vertically from surface to underlying parent material and large enough to show characteristics of all its horizons. Could be subdivided in hemiphion, humipyron, the living part where most soils organisms are dwelt, corresponding to humus form. Now, cop down in intermediary position. So it says that here it is characteristics also could be subdivided into hemiphidion, humipudon, this living part where most soils organisms live, and corresponding to humus forms. Now, cop down in intermediary position where most weathering of minerals affects, and lithopedon in contact with subsoil. There is then how much that is cop down, and then lithopedon. Soil texture is determined by relative proportions of individual particles of sand. Soil texture is determined by relative proportions of individual particles of sand, silt, and clay. That makes a mix of soil interaction of individual mineral particles, with organic matter, water, gases, via biotic and abiotic processes. Biotic and abiotic processes cause those particles to flocculate, stick together. Flocculate, that is stick together to form aggregate or pads. Here in this column is a soil profile is given. Darkened topsoil and reddish subsoil layers are typical of humid subtropical climate regions. So that's what it says. Now We say that flocculate stick together to form aggregate or beds. Where these aggregates can be identified, a soil can be said to be developed and can be described further in terms of color, porosity, consistency, reaction, acidity, etc. Water is a critical agent of soil. Water is a critical agent of soil, that's true. We can say water is a critical agent of soil. Okay, notes followers. Akhirat Raj Jaga Jaga. 14 minutes ago, it's but I'm just watching through this. दीवार तोड़कर उनकी चोरी 45 लाख पोस्टर ब्रांड को डाला. Alright, now let's close this. We are just taking worry for nothing. Okay, I continue my soil issue. Water is critical agent in soil development due to its involvement. Percentage of battery use now 60%. Water is a critical agent in soil development due to its involvement in dissolution, precipitation, erosion, transport, and deposition of material of which. Let's see. These are certain components of silt, loam, soil by percent volume. And you can say water, gases, sand, silt, clay, organic matter. It says water is 25%, gas is 25%, sand 18%, silt 18%, clay 9%, organic matter 5%, component of silt, loam, soil by percent volume. We can say water 25%, gas is 25%, sand 18%, silt 18%, clay 9%, and organic matter 5%. So 50, 5, 5, 10, 18, 26, and 26, and 9, 35, 35, 5, 40. So 4 balance, 4 to 6 to 8 to 9, 10. I think it's 100, okay. So components of silt, loam, soil by percent volume. You can say water and gases are equal, that is up to 50%. Sand is 18%, silt is 18%, clay is 9%, organic matter is 5%, and that is component of silt, loam, soil by percent volume. We have to just read it and see what it says. Now you can say water is critical agent in soil development. Water is critical agent in soil development due to its involvement in dissolution. Due to its involvement in dissolution, precipitation, erosion, transport, and deposition. So it is dissolved. It can dissolve. You can say water can dissolve soil. It can dissolve precipitate. It can dissolve. It can precipitate. It can erode. It can transport, and deposition of materials of which is soil is composed. Mixture of water and dissolved or suspended materials that occupy soil pore space, as mixture of water and dissolved or suspended materials that occupy soil pore space is called soil solution. Mixture of water and dissolved or suspended materials that occupy soil pore space is called soil solution. Since soil water is never pure but contains hundreds of dissolved organic and mineral substances, it may be more accurately called soil solution. Soil water is never pure water but contains hundreds of dissolved organic and mineral substances. It may be more accurately called soil solution. Water is central to dissolution, precipitation, and leaching of minerals from soil profile. Finally, water affects type of vegetation that grows in soil, which in turn affects development of soil. A complex feedback which is exemplified in dynamics of banded vegetation pattern in semi-arid region. Soil supply plants with nutrients. Soils supply plants with nutrients, most of which are held in place by particles of clay and organic matter, that is colloids. Nutrients may be absorbed on clay mineral surfaces. Nutrients may be absorbed on clay mineral surfaces, bound within clay minerals absorbed, or bound within organic compounds as part of living organisms, or dead soil organic matter. These bound nutrients interact with soil water to buffer soil solution composition, attenuate changes in soil solution as soils wet up or dry out, as plants take up nutrients, as salts are leached or as acids or alkalis are added. Plant nutrients, plant nutrient availability is affected by soil pH. So it says now plant nutrient availability is affected by soil pH. Like I said, these writes about this. Nutrients may be adsorbed on clay mineral surfaces, bound within clay minerals, absorbed or bound within organic compounds as part of living organisms or dead soil organic matter. These bound nutrients interact with soil water to buffer soil solution composition, attenuate changes in soil solution as soils wet up or dry out. Plants take up nutrients. Salts are leached as acids or alkalis are added. Plant nutrient availability is affected by soil pH, which is a measure of hydrogen ion activity. Which is a measure of pH, that's a measure of hydrogen ion activity in soil solution. Soil pH is a function of many soil forming factors and generally lower, that is more acid, lower when weathering is more advanced. Most plant nutrients with exception of nitrogen originate from minerals. Most plant nutrients with exception of nitrogen originate from minerals that make up soil parent material. Some nitrogen originates from terrain as dilute nitric acid and ammonia. But most of nitrogen is available in soils as a result of nitrogen fixation by bacteria. Nitrogen fixation by bacteria. One, in soil plant system, most nutrients are recycled through living organisms. Plant and microbial residues can say soil organic matter, you can say plant and microbial residue, soil organic matter, mineral bound forms, and soil solution. Both living soil organisms, microbes, animals and plant roots, and soil organic matter are of critical importance to this recycling and thereby to soil formation and soil fertility. Microbial soil enzymes may release nutrients from minerals or organic matter for use by plants and other microorganisms. Sequesters incorporate them into living cells or cause their loss from soil by volatilization. Volatilization, loss to atmosphere gas. Volatilization, soil by volatilization, that is loss to atmosphere as gases, or leaching, volatile. So it's of course little complicated. These are what we have to understand: formation, soil formation, or pedogenesis. Soil formation we have to talk about. It's also very important one. Soil formation, and we can say we have to be very important on this issue. Soil formation. Some we read, some we don't. We cannot read everything every way. Soil formation or pedogenesis is combined effect of physical, chemical, biological, and anthropogenic. Physical, chemical is soil formation we are calling pedogenesis. Pedogenesis, and that is combined effect of physical, chemical, biological, and anthropogenic processes working on soil parent materials. Soil is said to be formed when organic matter has accumulated. Organic matter has accumulated and colloids are washed downwards. Colloids are washed downwards. Living deposits of clay, humus, iron, oxide, carbonate, and gypsum. Living deposits, colloids are washed downwards. Living deposits of clay, humus, iron, oxide, carbonate, and gypsum, producing a distinct layer called B horizon. That is what it says. Again, we read this important. It says that soil formation or pedogenesis is combined effect of physical, chemical, biological, and anthropogenic processes working on soil parent material. Soil is said to be formed when organic matter has accumulated and colloids are washed downwards. Living deposits of clay, humus, iron, oxide, that is deposits of clay, humus, iron, oxide, carbonate, and gypsum, producing a distinct layer called B horizon. So this is very important. Soil is said to be formed when organic matter has accumulated and colloids are washed downwards. What happens is organic matter accumulates and colloids are washed down. Living deposits of clay, humus, iron, oxide, carbonate, and gypsum, producing a distinct layer called B horizon. This is sometimes somewhat arbitrary definition as mixtures of sand, silt, and clay, and humus with sport, biological, and agricultural activity before that time. These constituents are moved from one level to another by water and animal activity. As a result, layers or horizons form. Soil profile. Alteration and movement of materials within a soil causes formation of distinctive soil horizons. However, more recent definitions of soil embrace soils without any organic matter. Such as those regoliths had formed on Mars and analogous conditions in plant earth deserts. An example of development of soil would begin with weathering of lava flow bedrock. An example of development of soil would begin with weathering of lava flow bedrock. which would produce purely mineral-based parent material from which soil texture forms. Soil development would proceed most rapidly from bare rock of relevant flows in a warm climate under heavy and frequent rainfall. Under such conditions, plants in first stage nitrogen fixing lichens and cyanobacteria, then epiphytic higher plants become established very quickly on basaltic lava. Even though there is very little organic material, basaltic minerals commonly weather relatively quickly according to dissolution series. Now let's say plants are supported by porous rocks. Plants are supported by porous rocks as it is filled with nutrient bearing water that carries minerals dissolved from rocks. Crevasses and pockets. Local topography of rocks would hold fine materials and harbor plant roots. Developing plant roots are associated with mineral weathering mycorrhizal fungi that assist in breaking up porous lava, and these means organic matter and finer minor mineral soil accumulate. With time, such initial stages of soil development have been described by volcanoes in Salzburgs. So this is about soil and so many more files. Let's go to how soil formation proceeds is influenced by as 5 classic factors that are intertwined in evolution of a soil. They are parent materials, climate, topography, there's relief, organisms, and time. When recorded the climate relief, organism, parent, time, they form acromon cropped. Now, physical properties we'll study later on, and I think we'll go back to file now currently because we have cannot be bored by this, and now we have certain here. Let's say we're talking of soil improvement, that's why I took you to some specific discussion on that, because just blindly studying something doesn't mean in engineering. We have to understand much on that. Only then something can be called competent education, competent learning. And we are trying to learn competently. That's a very important point. So if I say blinding study, then this layer comes of aggregate coarse dust duly water. So blinding says since soil bearing capacity is not safe. Since soil bearing capacity is not safe to allow heavy structures of this sort, soil improvement is conducted by forming improved layer of 300 mm deep as explained later. Now this layer composed of aggregate and coarse dusty duly watered and compacted so that it should also function as a coarse graded strata. On this layer, an application of tape-crete coating was polymerized cement it is. An application of tape-crete coating was carried out for concrete protection. Coatings of tape-crete were covered with a plaster screed for protection. Now we say this layer composed of aggregate and coarse dust duly watered and compacted so that it should also function as a coarse graded strata. On this layer, an application of tape-crete coating was carried out for concrete protection. Coatings of tape-crete was covered with plaster screed for protection. Preparation of blinding was affected by blinding concrete laid to whole area. Blinding was cured for within 3 days or meeting requirements. Now foundation. I think before this I have to give me time. You have to give me time. Let me just break down to some values so that you can read this for a couple of minutes. Of course, it's very small font, but maybe I don't know if you'll be able to read that in full screen only. So, give me 5 minutes. I think it's better to go and come back. Let me go and come back. I mean, I think I should be better if I go and come back. And you can say 5 minutes only. was taking about in this case is that we're taking about this, of course, foundations. It's talking of and it's talking foundations in this case. We say, what is foundation? Setting out foundations draft, setting out for foundation draft. That's what it is. Setting out foundation draft. A part of foundation beam was affected. That's what it said. Setting out for foundations raft, a part of foundation beam was affected. Preparation of raft included placing fabricated reinforcement. Preparation of raft included placing fabricated reinforcement, fixing of forms to sides of proposed raft, fixing spacers, cleaning hole, RCC space, etc. Special waterproofing compound was procured to be mixed with concrete for areas where a water tank portion was included within raft itself. Concrete mixing and pouring was carried out in one day successfully, followed by application of wooden finish and curing for required number of days. Work started for a bright part of foundation beams and all included activities respecting form fixing, rebars fixing, box out, inserts for services, water tank, slab, etc. were prepared. Concrete was mixed for this pour to be mixed with self-leveling concrete compound. During this period, this is pour one and sectional beam side tried to open, but immediately was controlled. Curing was effected for required number of days. Now, in this period, I said raft. Please don't take it the structural raft, because this was not a structural raft. This is, portion between beams. Concrete, I do not want to fill with soil, but with concrete with nominal reinforcement of 8 mm, 15 centimeters or 20 centimeters, 200 centimeters both ways, only for that purpose, so that it becomes watertight. It's not structural one. And only raft it is, but there's a beam which is actually have seen. Beam, its portion, it's very important one. I still remind you what I'm talking of here, and not this file, sorry, other file. I can close this file for timing because it should not confuse me and you. And I think the cycle is good. So I'm saying is something here. I'm talking of confusion at all, and that's this one here. You can see this. This is soil improvement, and this is spreader below beam. I can say I just use this area for UDL, uniformly distributed load direction, and this is structural beam. And raft, as I'm saying, is here only for filling in this portion, not this raft. This is just for clarification. I'm giving this, and this beam is continuous around, connecting all. It's important also to share with you people. So I said here is in case of foundations. I was talking about foundations. That's what it is. Foundation. There is here setting out a foundation raft. A part of foundation beam was affected. Preparation of raft included placing prefabricated reinforcement, fixing of forms to sides of post raft, fixing spaces, cleaning hole, RCC space, etc. Special waterproofing compound was procured to be mixed with concrete for areas where water tank portion included within itself. Concrete mixing and pouring was carried out in one day successfully, followed by application of wooden finish and curing for required number of days. Work started for bright part of foundations beam. Structural part actually work started for bright part is a vertical part of foundation beams, and also include the activities respecting forms, fixing, rebar fixing, box outs, inserts for services, water tank, slab, etc. or prepared. Concrete was mixed concrete was mixed for this pour to be, concrete was mixed for this pour, you can say, to be mixed with self-leveling concrete compound. For this pour to mix with self-leveling concrete compound, during this pour, one sectional beam side tried to open but immediately was controlled. Curing was affected for required number of days. Basement wall column starts. This was about, now it was actually, to be very frank, this portion, which I'm talking of foundations for structural portion, structural beam, which is actually footing in this case, not independent or isolated footing, but a kind of boxed footing or mat beam footing, you may say, or you may call it continuity of beams. They are in continuity of beams. That's very attractive here, and that's where point arises in a complete way. So it is that one. This structural beam was very complicated and poor, and for portion where water reservoir we designed in place of backfill water to stand there, that portion was used for waterproofing concrete. In that, others are normal concrete, and this was 400 mm width uniformly, and actually your columns would come out of that. I considered this as floor level, so you can see there's no stub column in that. Stub column, only reinforcement exists in this beam. So you may say that this whole beam is a stub column. You may say that this is a stub column or stub raft walls, whatever name you give. I give frame beam foundation, and columns, concrete start from this beam top and still goes into down. So there is no stub column in that case. If it's stub raft, you may say, or you may say whatever you can call it, there's no name. It's a kind of combined footing for all. But that footing is not independent. That footing is like a stove, but all columns, foundations are combined together. So that's what it is, and it's very strong in fact, because there's just no cantilever movement in this, no cantilever bending moment, on foundations. And of course it's stronger because in cantilever movement you have to take WL square to upgrade direction. You have to write resistance for that, but here there's no such question. It's fixed completely on within. That is WL square, or 24 can be taken up to that. We took lesser than that, so it's okay. Means it's fine. It's something interestingly done. And of course after that we have to pour this portion of beams, structural beams, which is about 1 meter in depth, and in layers to pour it to complicated steels in, and then further overlapping columns, double columns, starter bars of columns remain exposed, and all beams finished that way. And I think it is much better than your normal footings. So I always prefer such type of footings. This is one part here is it, and also you have to be sure about this. So basement walls, columns, startup will take next time. I think it's not time for me to go continuous on this. It's about we have to think of this issue that we have taken in. It's of course it's only 2 pages, no problem. Basement walls, column stays will take up also this very important one. To understand, you have to see how to do it, what ways to best way for this, how dimensions are worked in this. I don't have anything stair portion here, which we have to discuss and see how stair was given. It's very important point of stair. I think here is something. Oh no, this is not that one. Ground code is so we have to see a stair, how stair can be done. Bottom and not for that one. So we can say yes, no. Actually I want to say is, let me see if it's not that stair, but just an example I want to give. I will give stair for example. I will give stair here. You can say stair here. This portion, for example, you need this dimension, and also same here, this dimension for whatever you can say, and that's an important point. How can you make calculation is not easy for this, and that's you can say no, it's not easy for that, and that's still 300 percentages. So it's okay, it's like this, and we say, well, I'll come back to that one. No, point is that we have to see what else, and that was my file here. You can see here's my name board again. I say certification, here's coordination engineering we are discussing, and we'll discuss together with this. It's very important part, coordination engineering. You can't do without that, coordination engineering. And as you can say, what you mean to say is quality file, that is say here, quality engineering. So many files I'm doing together because of that reason. It's house construction here. This is a very important one, house construction, and this will take us to many folds of. Now we have here, we can start. It's time now that we should understand coordination, communication. I'm trying to communicate with the people for improving quality and improving coordination issue. I'm very fond of coordination because coordination keeps my brain intact, and it can see that you're thinking something, and coordination can solve problems of project. Because coordination means whatever problems do we face, we have to discuss all factors involved with that problem. We cannot leave any factor behind. We have to be very sure of that. But some people, some people are different. So we start this point we have to consider here. All time, every time, we cannot just run away from this. We have to be specific for this. In this issue, I've taken this against that. Engineering coordination is that very important. It cannot be taken for granted, and that's why I included my questions here for everybody. And these questions are quality and coordination. What do we engineer think on for issues as mentioned? How many of ourselves do conduct works for quality and coordination engineering? It's not right time to contemplate and deliberate on this subject. Can good industrial practice be achieved without moving through quality and coordination? Can engineering designs be reliably carried out without involving quality and coordination together? And then we have talk of communication, etc. for various projects. And my point of view is now it's quite interesting as well. That for reliable quality engineering works deliveries, coordination engineering is a must. A professional engineering mode for all. We have to be specific with that. It's no end. It cannot be any end. There's no beginning. It's already begun. It will continue forever because there is no end. There's no end topic on coordination, and there's no end topic on communication. It's lifelong study, you can say, can move lifelong. We have to think logically, and that's most important. If something you feel you come in contact with and feels I'm wrong, I'm not professional in that way. Point it out better. You have to understand these points very well. Now I'll take your leave for time being, and I think we will come back tomorrow next time, and we'll take care of this again.